So let's see now how to scan. So scanner is on, connected. Okay, let's see first how to scan with Vertex, the basic software. So let's start Vertex. Okay, when software is connected and everything is working, if I go under the service mode, here I have to see in a few seconds the two flags with a green color, okay? And I'm in a live session, okay? So then, okay, here I can load an existing job and add scans or modify something or create new meshes, or I can create a new job. Okay, being a basic software with Vertex, you have different ways to run a project, a scan, but basically two ways. First, you have a wizard mode, and second, you have an expert mode. So expert mode is the last icon here on the left. The other four are 4 different wizard projects. Wizard project means that depending on what you choose, so easy object, medium complexity object, hard object, coin, the software is creating for you a workflow, a sequence of steps, and you have to stay on the workflow produced by the software, okay? So for example, easy object means to scan the object in 2 different positions, okay? The software will ask you to place the object in its first position, scan it, edit the scans, then place the object in its second position, scan it again, clean again, and then the software will align the 2 different scans and produce the mesh, and you will be ready to export. Everything will be done according to the wizard. So you will be free to jump from a step to another, but always inside the wizard. Expert, on the other side, means that you can do what you want without any kind of wizard. So you don't have nothing telling you what is the next step. You need to know where to go, but you are free to go where you want. Okay, let's, for example, first do a job, a wizard job, a wizard project. Let's do, for example, a medium object. Okay, here I type the name of the job 1. This name will be important in case of I will need to enter the database and recover my old job. And then I can confirm and go ahead. Okay, here we are in our scanning interface. Being in a wizard mode, here we have a list of sections. So if I click on the sections, you see that the software is asking for the acquisition of the position 1, then the position 2, then it is the software will run an alignment phase, position 2 on the position 1, and then it will create the final mesh. For example, if I move back, return home, and I create another new job, and I tell the software it is an hard object, obj2, and I enter. This time, instead of 2 positions, the software is asking for 3 positions. And of course, the strategies, the sequence of single scans is different, but everything is defined inside the software. You don't see number, you don't see nothing. You just click on the complexity of the object that you want to scan. Okay, so yes, let's go in this way. Here I have 2 ways to run the wizard. The first one is to forget the sections on the left. Just read here on the bottom of the screen. It asks for the position 1. So of course, I take out my holder, okay? I fix some gum on the holder, and then I fix my object on the gum. It is a black gum used to play by the kids, but you can use also other materials if you want to fix the object. The object is a fish shell, okay? Okay, here I decrease a little bit the quantity of the projected light because the object is white. And then here, this is for us the position 1. So look at the menu here on the bottom. It is always the same every time I have to run a scan. Okay, so here I can enter the options predefined by the software if I want to modify something. So for example, now I am scanning using standard resolution. If I want to increase the resolution, I have to click on the full frame scan. Okay, I can also modify the acquisition type. Every time I move from the left to the right, I increase the scanning time, but the quality of the results is then better. Okay, I can also give the software some information about the color, and I can also specify a kind of cleaning strength. If I don't enter this menu, the software is working according to the parameters predefined inside the wizard project. Okay, so here I can import existing scans if I need, in case I need. Okay, and here is where I start the scan. Before starting the scan, take a look at the dark line. Here I see the dark line on the object. The focus is good, I can go. Focus is good means I'm not in a condition like this one, for example, where the focus is very, very bad. Okay, if it is bad, I can modify the slider below the projector and set the correct focus. Okay, then we can scan. If I hit Control before clicking on the icon, the software does a single scan, a fast scan, in order to define the cutting plane. So this is my shell, okay? Then I click here, okay, yes, it works. Everything is red, I set this, everything is red will then disappear during the scan. So now I click again on the acquisition without clicking on with Control. Just click the left button of my mouse. Okay, and now the software is scanning. Okay, you see that the scanner is moving and acquiring different positions. Each time we see a piece of object appearing. Okay, for zooming, you use the wheel of the mouse. Okay, depending on the point where you are with the mouse, you also do some pan. Okay, for rotating the object, you keep the right button of the mouse clicked, and you move the mouse and you rotate in this way the object. Okay, if I just click on my interface with the right button of the mouse, I have the other options available. So undo when I have something done, redo when I do an undo, save scene when I have something ready to be saved, the different views, and the rendering mode. Okay. So here, if you see the scanner, we did a trajectory, and here is the result of our scan. If we don't like that scan, okay, we can integrate. Integrate means that when I click on follow view, the scanner is moving, and according to the position that I specify, moving the object on my screen. Of course, with the limitations coming from the two axes. And when I click on acquire this position, we acquire that point of view. Let's say this is a good feature, but not the most used one, because when I run a strategy, I acquire 40 points of view. And if I add one, I add nothing. Of course, what remains below the object is something that I cannot acquire integrating. I can acquire that only adding a new scan, but moving the object in another position by hands before. So what I can do here is now to click on next. So I let's say confirm this scan. Here is where the software, if I click here, now the acquisition of the position 1 is done. The software is asking me to clean this part. Okay. The cut base is an interesting tool. You have this plane parallel to the base of the object of the rotary table. If you click on a point of or you move the slider, the software selects in red, everything is below, and when you click on apply, it disappears. Let's say in this case, the best is to click on the polygonal selection, and then if I hit the left button of the mouse and I keep it clicked and I move, I do a freehand selection, and then to close, I double click. Everything is red. When I click on cut, disappear. Okay, and here I have another piece of object to be cleaned. I can use the same tool, but this time I don't keep the button click. I click one time, then I move, then I click, then I move, then I click. Every time I click, I change the direction. Okay, and to close, always double click, and then I cut. or I cancel using the cancel button of the keyboard. If I want to come back, undo, I have back my point, and I can undo again and again. And if instead of clicking on next, I click on previous, I cancel the whole editing section I'm doing. Here is another important tool to remove the outliers. Outliers are for us points far from the surface. When you use the standard resolution, they are not too many. When you use the high resolution, you can have outliers. So depending on the parameters that you select, the software is finding the outliers, and when you click on remove, it removes them. Of course, it is an erosive filter, which means that if you run several times the same filter on the same object, you erode the object and you create holes, okay? So now we go ahead. Here, now the software is asking for the position 2. So we moved to the second step. If for some reasons we want to scan the position 3, we can click on position 3, and then the software will ask for the position 3. If for some reasons we want to rescan the position 1, we have to click here and we come back to the position 1. So two ways to run the wizard. First one, we forget the sections and we just read what is on the bottom, on the top of the screen, and we follow what it asks. Second way, we click on the steps and we go where we need to go. Okay, now let's move the object and fix a second position. Okay, again, we have the same scanning menu. One more time, we hit Control and we define the base plane. Okay. Click on this point, everything is below is red, set, next, and then we acquire. Of course, we moved the object manually, so the second scan for sure will not be aligned to the first one, but the software will give us the possibility to align everything with an automatic alignment. And in case of errors or alignment not well done, we will have the possibility to fix the alignment specifying different points on the different clouds. The speed, the scanning speed is of course depending also on the power of the computer. It also depends on the scanning, on the acquisition type that you have defined. So fast is the fastest one. If you go to normal, it takes longer, but results are a little bit better. If you go to robust, again, it is a little bit slower, but better. And if you go to very robust, it takes a little bit more time, but again, the results are better. Let's say the big difference is not on the white and opaque object. The big difference between the different acquisition types is when the object is not perfectly white or opaque. So we did the scan of the other position. Now we move next. Here it is exactly the same menu we saw. We move next, and now we select what or we can also do different. Sometimes not this case, but it is to show how to do. Sometimes takes less time to select what we want to keep. So the object, and then instead of cutting, we crop and we cancel everything is not selected. Okay, so we move forward again. Now the software is to the third position. Okay, so let's again move the object, and then we don't modify nothing here. We go and scan. Here you don't see the scanner, but every time we see a part appearing, the software is moving, is rotating the object and tilting the object according to the strategy defined for the hard object wizard mode. Okay. We are more or less done with the third acquisition. Okay, now we go next again. Again, we cancel what we don't need. So let's select what we don't need. Okay. And we move, here we are at the third step. We move forward, and now the software is in an automatic way finding the alignment between the three different scans, not aligned because we moved manually the object. But you see that the software found the alignment in a perfect way. If for some reasons I want to modify something, I have, of course, 3 objects and so 2 alignments. I can click on the alignment that I want to modify. So, for example, this one or this one. Okay, let's do, for example, this one. Okay. So this is my red object. This is my green object. Here, when I click on show floating, I see together in my main viewer. If I more or less place the 2 objects with the same orientation, like they are now, and I click on more or less the same point on the green object and also on the red object, the software finds the alignment. Okay, of course, we use the point specified with the mouse only for placing the red close to the green. Then we run an automatic ICP session where we find the smallest distance between the 2 point clouds and we find the perfect alignment. I say that because even if you specify instead of 3, you specify instead of 1 couple, you specify 3 couples of points and you zoom a lot, it will be impossible to find the same point 1 on the left and on the right, the same point 2 on the left and on the right. So we are not precise when we specify the points, but they are used only for placing the red close to the green. Then when they are close, the internal algorithm is able to move the red and find the best overlap with the green. Okay, so we can also improve the alignment if we want, or we can reset it and redo it. Okay, and we go next. Every time the software doesn't find the correct alignment because maybe the object has symmetries or it is a 2 geometrical object, it gives us the window where I have to specify the points on the red and the points on the green. And then we move next. Now we are in a wizard mode, so we already have the 3 point clouds aligned. The software is already creating the mesh. So I needed to specify nothing, no parameters about the mesh, but it is because we are in a wizard mode. So depending on the wizard project we are working with, we have a predefined scanning strategy and a predefined set of meshing parameters. Okay. Of course, you cannot control everything in this wizard mode, but it is very easy to start from the beginning and get a final mesh. Also, this time, it's a time depending on how many points we want to process, and of course, on what kind of computer we are working on. If I can give you a suggestion, the best is always to use a desktop solution. This one that I'm using is a laptop. This is not the best solution because all the components mounted on a laptop are always coming with the mobile release. So if I have a video board mounted on a desktop and the same model of the same video board mounted on a laptop, let's say NVIDIA RTX 4060, okay, laptop version and desktop version. There's a big difference between the 2 video boards. The one that is mounted on the desktop is much more powerful. Why? The reason is because when you work on a laptop, you have battery. So the concept of a laptop is to save the battery and work not for 5 minutes, but we all buy the laptop because we need a portable solution to open it when we are at the airport and use it when we are on the taxi and use it when we are at home. And so it has to stay on for some hours. For this reason, all the components, CPU, video board, RAM, everything is mounted on the laptop, is in its mobile version, which means that it has been developed for using less power. But when you decrease the power, because you want to save the battery, when you decrease the power of a CPU, of a GPU mounted on a video board, means that you are reducing a lot the speed, the computation speed. So the same processor mounted, the same CPU mounted on a PC, on a desktop PC, and mounted on a laptop, on the desktop, it works 10 times faster. Anyway, here we have the result. Here is not the point cloud. Now, if I turn on the wireframe and I zoom here, now we have triangles. Okay, we are having a scanning coming from the standard resolution optical head. So it is possible also to scan with the high resolution head. Okay, now I can export my file. So export, I just specify a folder, the file format that I want to have, and then I click on OK. Or if I want, before exporting, I can run some editing, always on the triangle mesh. Okay, you see that we have all triangles. Okay, editing means that I can select parts and cut. I can fill holes. If I have holes, I can fill them. Okay, I can select clicking on the hole or select by size. Okay, and the policy used is always to stay in tangency with the boundary. I can flip the normals. Okay, I can run the topological analysis. It's a kind of mesh doctor for fixing the mesh problems. I don't see nothing if the mesh is a good mesh, but the software is cleaning all. If I have there's very small holes, the intersecting triangles, the not connected triangles, all the not topologically speaking perfect situation triangles. I can also smooth my mesh. This is a smart smoothing. Okay, here depending on the parameters, depending on the sensitivity. If I start from 0, everything is gray. If I increase the sensitivity, the software, the more I increase, the more the software finds blue and orange areas. Orange for the software is a small radius or an edge. Blue is positive radius or edge. Blue is a small negative radius or edge. Okay, so then when I specify a certain strength and I tell the software, okay, smooth, only what is gray is smoothed. What is orange and what is blue is enhanced. So we are building better edges, but at the same time we are smoothing the flat surfaces, because if I smooth the edge, then instead of an edge I have a round. Okay, and of course I can always undo. And the other one is the decimation. So I am now working with more or less 1 million of triangles. Okay, I can decrease the number of triangles in order to have a smaller file. Okay, so the software, when I click on decimate, will substitute the small triangles with bigger triangles, trying to remain to give me the target number of faces. Okay, at the end, it's a set of a few tools without a lot of parameters, a few easy tools to make the object better before the exportation and before importing it in a software like ZBrush in order to do the rest of the work. Okay, so when I export, I tell the software export on my desktop, the STL, and then it opens. Here I have my result, okay? And this is my triangle mesh. And this is everything about the wizard mode. When I return home, of course I save. If then I want to come back to my original project, obj2, I open it, and this is my object. Or we can also run a project in a expert mode. So let's come back. So now we do a new job. We call it expert, and we specify expert mode, and we go. And we acquire, here you see that we don't have any kind of wizard, just have this button for saving the project, going to the service if for some reasons I want to calibrate or return home. I have my toolbar, very easy toolbar, scan, edit, and if I edit a point cloud, it gives me a set of tools. If I edit a triangle mesh, it gives me another set of tools. So editing, alignment, and mesh creation. Exactly following the standard working workflow. So first I scan, then I clean, then I scan again, then I clean the second one, then I align the second on the first, then maybe I scan a third point cloud, but I clean, then I align, and at the end I select everything and I build my triangle mesh. So let's scan. This time I have different options. I can select an already created strategy, okay, which includes different positions and different parameters, or I can create my own strategy. So, for example, let's scan again the object we did a few minutes ago. Then rotation position, so a step of 36 degrees. We scan with the tilting angle of minus 30 degrees, which means that we scan the object from a top position, okay? Then we run a scan at 0 degrees. No, let's do one at 0 in order to scan in a better way the lateral surface, and then we do another one at 15 to scan 20 to scan more the lateral surface, okay? And we call this scan advanced trajectory 1. Let's also change from fast to robust, and this time let's do a full frame scan. So let's use the full resolution, okay? And we go. I forgot to define the cutting plane, so I can cancel if I want, or I can leave the scanner scanning. You can see that I'm scanning also the base, but then as we saw that we have all the tools for cleaning what is not needed. Okay, using the full resolution, you see on the point cloud that you have more details. And of course, every time we move the object, we scan, we move, we scan, and we go ahead until the end of the trajectory that we have defined. This time, we are doing 3 tilting angles, each one of 10 positions, so we are acquiring 30 single point clouds aligned in just one big point cloud. Okay, 42%. Okay, so we're done with the first position. Okay. Here we can run the editing if we want, or if we want to confirm, then we can come back to the editing, clicking here on the editing button. Okay, we find exactly the same tools. So we can clean using the cut-based tool. Okay, we click on the point. Okay, then we apply, everything is disappear. And then we run some more cleaning. Okay, with the correct tool, we go and we select this part. Okay, then we cut the selection. And then we can also do something like this. We select the whole object and we crop. If we still see some small parts inside, we don't care, because then they are disconnected, and during the mesh creation process, the software will cut them. Okay, because they are disconnected. Okay, so we can confirm, or we can run the out layer cleaning. Okay, remove out layers. Okay, and we go next. So the first scan is done. Here we have a tree where we see all our results. Okay, now we can scan the second position. So a new scan, always let's do an advanced trajectory. We call it 2. And this time we can do 10 positions at the 0 tilting angle, because we have already acquired a lot of the object. We just need to complete it, scanning some lateral surface, and we go. Okay, again, the dark line is good, the focus is good. Okay, and we scan. But now we are scanning using the standard resolution, and we are using the fast scanning mode. So we don't like that. We move to robust and we use the full resolution, and then we scan again. And we are overlapping the scan that we did a few minutes ago. Okay, again, every time you see a new part appearing, means that the scanner moved the object and the software has acquired the new position. So here in this mode, I don't have to stay on a certain wizard. I'm free to define my strategy, to define my scanning policy. Okay, so I go next. Again, we clean. Okay, and we move next. Now, if we select both 1 and 2, of course, they are not aligned because we moved the object manually. Okay, so the next step is to select the one that we want to move and click on the align. And this is what we are selecting here is our reference. So the scan 1 will remain fixed, will be our fixed object during the alignment. The first one that we have selected, so the scan 2, will be the floating object. So we are moving the 2 on the first, the second on the first. And always when we run an alignment, the software does an automatic alignment section based on the features. Of course, when the features are too many, or if the object doesn't have features, so in this case, there are too many, it asks for some help. Okay, so I move the object with the two objects with the same orientation, then I click here and click here, more or less, they are the same point, and here we get the final alignment. We can improve, and we go next. And then we can decide if we have to scan more or if we have already acquired what we need. So for example, here we have an hole, but it's an hole on a smooth surface. The software will close it in a very good way. Here, some data are missing. So for example, we want to scan in order to fill with the scanner the holes that we have here. Okay, let's do that. We start a new scan. Again, we do an advanced trajectory, call it 3. We need to scan from a top point of view. So let's do minus 20 degrees at least, and we do other 10 acquisitions. Again, we move on robust and full frame, and we scan. So we go ahead with this process, scan, clean, and alignment, until when we don't see what we need to scan, already scanned. Talking about the tilting angle, when we specify a negative angle, means that the tilting arm is moving the object in order to scan more the top surface of the object, more to scan the object from the top direction. So it moves more close to us, okay? When we specify the positive tilting angle, the arm moves more inside the scanner in order to tilt the object and acquire more the lateral surface of that. Okay, here we have the new scan. We do exactly what we did. So let's find a position where we can do everything with just one selection, like this one. Then we crop again, and we go. Of course, the third one is not aligned with the second, but we click on the third, we align with the second. Again, the software is doing the automatic alignment. This time it works because we have a lot of parts in common, so we don't need to adjust the alignment. Okay, and this is our object. Now, here, if we want, we can merge in just one point cloud. Okay, so we have just one point cloud, which is the sum of all the point clouds. Okay, we can run the global optimization, which means that the software is moving a little bit each single scan in order to find the best overlap with the rest of the scans. Okay, also the global alignment, the time required for the global alignment is depending on what kind of computer you are using, and of course, how many data you are processing. Okay, at the end of the global alignment, normally before creating a triangle mesh, we run a global optimization when we put together more than one scan, and then we select the required point cloud, the one that we want to translate into a triangle mesh. Of course, if we want, we can still edit this point cloud, or we click on the generation of the mesh. We select what kind of detail level we want to have. Depending on the detail level, if we say high or very high, the software will create more and more triangles because we are asking the software to follow all the details, and then we click on the mesh generation. So this mode, compared to the wizard mode, has more or less the same tools, okay? But here, you have the freedom to do what you need and what you want according to your workflow. You don't have to stay on a fixed strategy. So what usually happens when the client doesn't have too much experience is to start with the wizard mode in order to be able to produce good results since the beginning after the training, and then it moves to the expert mode to be able to improve the quality of the results, applying its own scanning strategy at the end. And of course, now the time required for creating the triangle mesh will be longer. Why? Because we are now working on a full frame, on a full resolution scan. Consider that when we use the full resolution, for each pixel of the camera, we produce one 3D point. Okay, when we use when the full frame is not enabled, so we use the normal resolution, we use 4 pixels for creating one 3D point. So the point clouds we are having now have 4 times the points we had in our first project. Of course, it always depends on what kind of object you are scanning. If you have an object with details, makes sense to, and you need to scan the details, of course, makes sense to use the high resolution. If you don't have an object with a lot of details, or you don't need the details, makes no sense to use the full resolution. Consider always that the time needed is, of course, increasing because you are working on much more points. But if I multiply by 4 the number of the points, the time needed is not multiplied by 4. The increase is not linear. It's an exponential increasing. So if I multiply by 4 the number of points, on the other side, I multiply by at least 12 or 16 the time required. And of course, at the end of the process, I have a bigger triangle mesh with, of course, much more triangles. If I want to see in a good way small details, I need to use very small triangles. This software, same is for Vertex Pro, is also able to work in parallel. Here we are creating the mesh, but you see that the scanning button is still on. So if I want, while it creates the mesh, I can acquire, for example, I can run a new scan. Or if I have other scans and I want to edit them, I can do that. Or if I want to align, I can work in parallel. So at the end, I'm not forced to stay here waiting for the mesh creation, because I can do other stuff during the mesh creation. Of course, for working in parallel, you need a computer according to the features that we ask for. It has to be a good computer, and better if it is a desktop and not a laptop. Okay, 100%. This is our result. This is our triangle mesh. Okay. Clicking on the edit selected data, we see the same menu we had in our wizard mode. So we can select parts and cut them, fill the holes. We can click on the single hole and fill it. Okay. Or do something like that and fill selected. Okay. Click on control and select a piece of the object, of the big object, and it selects everything is connected. And then we crop. Okay, we can run a fix problem session in order to fix the topology of the created mesh. If we turn on the wireframe here, the triangles are very small compared to the triangles we saw when we created the other mesh. And if we enter the decimation, here we are having 3.8 million of triangles. The first one, the first project we did was with more or less 1 million of triangles because of the lower resolutions, the lower resolution used. Okay, so then we go next. And then if we want to export, just click on the export button. Again, we have to specify a folder. We can add a prefix or not, and we click on OK, and then we have our mesh exported. And exactly the same that we saw with the wizard mode. If I then come back to my database and I click on my expert project, here I'm loading everything I have saved a few minutes ago. So if I want to come back to a project after a week and add parts or do new stuff, I can do that.